Hello everybody, this is Schwab again. Today I would like to introduce a Compuplast VEL Profile Digitizer. This is a new development which was made recently by a new young programmer of Compuplast. His name is Petr Přindiš, and also I was participating on this project as an advisor. So what is the program used for? These are some of the typical profile products. These ones you can see in any profile company, and whenever you extrude a profile like this, you ask yourself, how well does it match the required final shape? Well, it is very important to really be able to compare the extruded dimensions to the required profile dimensions. Well, before we proceed, let me start the program. I can go to a virtual extrusion laboratory. I have a 6.10 beta here, and I will go to Extrusion Experts because I have all the modules there as I'm a developer. Of course, we need to go to a profile die because the VEL Profile Digitizer is tightly linked to a profile die module. By the way, this module is also relatively young, and it's very capable to design even complex profile dies. So if you want to invoke a profile digitizer, you need to go to a project data, and then you will find this button here. Well, maybe the button name will change in future, but certainly you can start the profile digitizer straight from here. So we can invoke the program straight by using this button. Let me stretch it, make it full screen. The need for profile digitalization is obvious when looking on any profile shape. We certainly need to use it in a trial and error procedure to evaluate the experiments, to exchange information between the designer and the processor. But it has also a very good potential in serving as a quality control tool. And alternatively, if you like to copy a competitive profile shape, you can certainly use it through a profile digitizer. How we normally evaluate an extruded product shape, how that is done in industry nowadays. First option is to measure the dimensions using a caliper. So if you have any shape, you can simply measure 1, 2 more dimensions. But of course, for complex shapes, this is quite difficult. You can scan also the profile on a scanner. However, the scanners create sometimes hazy edges, and it's not very easy to do that. That's why people have created professional scanning devices, specialized scanning devices for profile scanning, but they're relatively costly. Also, we can use a semi-transparent paper and project the profile shape to that paper and compare to a required shape. Well, these are the traditional methods used in industry. However, Compuplast idea for digitalization is much simpler. We would like to use a regular phone camera to make a photo of your profile product, and then evaluate the image in a computer program. So this is what we call VEL Profile Digitizer. This is a typical photo of an extruded product, and it is clear that it has some difficulties, it has some distortions. Most common distortion is the perspective distortion. You can see on this paper with the title Hello, that the paper is really distorted, and we need to do some corrections to come to the orthogonal picture where we can measure the real thickness of each letter or dimensions. So we use the 4 points warp to do that. We have also barrel distortions, which we need to correct for. You can see here the blue lines, which are before correction, and the lines which are after the correction. Well, all these corrections are used to feed the program by an information which we call calibration. So we calibrate the camera and we get something what is called a transformation space. The Compuplast Profile Digitizer works in few steps. First thing which you need to do is calibrate your camera. You do it only once forever. That's a good message. And then you need to follow 3 very simple steps. Take a photo of an extruded product, transform the image to a correct space, and then finally evaluate that shape. All right? So this is what the program is doing, and we can see step by step how to proceed. So when you open the program for the first time, you will be forced to create a new project. You can click New Project, and then you can choose if you are going to use a scanner. Of course, then this is going to be very simple to bring the image because no corrections are needed. Or, alternatively, you can use a camera. You can use a regular phone camera or a more advanced cameras. But of course, then we need to do some corrections. And these corrections are linked to the type of the camera. So we have to specify the camera first. So before we go here, we need to have some camera in this list. As we don't have any, I need to go to the new camera settings and prepare my camera. So what we need to do is we have to show the calibration pattern. This is a calibration pattern. And now you take your camera and make about 20 pictures of this board straight from the screen. And you do these pictures from different distance, from different angles, from different directions. And once you do, you can just load these images to a computer and bring them here. So I have an example of that already prepared here. You see, these images are really images of a screen, so you don't have to print the board. You really do the calibration images straight from the screen. So you select all, and you click Open, and then you simply do Calibrate. Now what the program does is he makes or he extracts from these images all the information he needs to do in future for successful image corrections. So he's detecting the black circles, and from there he gets the corrections. All right, we've done. And now I can only give the camera a name and save my camera. From now on, the camera is available among the cameras, and I don't have to repeat this, at least for this camera, anymore. Well, there's another thing I have to prepare, and that is we have to prepare so-called board. The profiles will be taken on so-called Compuplast digitizing board. These boards are available here. We have already 3 predefined boards. These boards are available in the program as a PDF, and you are kindly requested to print them out on a relatively hard, thick paper. I recommend that you don't print it on regular printer, but you ask your Photolab or your Xerox company nearby to do it for you. Each board may have different dimensions, and the dimensions are identified by these 2 black bars. In fact, we measure the outer edges of those black bars. So as you can see, you can define also a new board for yourself to make, let's say, bigger profiles, because you always have to place the profile slice on this board before you make the image. Well, I've done already that image. Let me show you. Here I have my image prepared. As you can see, I'm always marking my pictures of or my photos of profiles. I'm marking them with the height. So I have to identify the height and also which board I was using. Of course, it's also written on the board. You can find it here, the dimensions, so you can identify it also later on. But it's good habit. And now you need to specify the height of the profile. It was 36.5, so I have to specify it here. I need to choose my camera. I have to choose the board type. This one was small, and I click OK. As soon as I click OK, this image, which is distorted, it has perspective distortions, it has barrel distortions, it has some other distortions as well, the picture will be, or the image will be automatically corrected. Now we have it corrected. So this first part of correcting the image is already made. This is mainly what the program does for you. I know it was very fast, but it's meant to be fast. So now we come to a second stage of using the program, and that is evaluating the profile shape. There are several options how to evaluate this shape. One possibility is to measure the dimensions, measure angles. Also, we can import so-called final profile shape, the required one. We import it as a DXF, and then we can compare this DXF to this image, and also measure how does it differ. And as a last option, we have the ability to create an outline and export that outline to DXF for detailed evaluation, let's say in a CAD or profile die module of Compuplast. So let me show you one by one how we evaluate this shape. The first option is to use a ruler here. We call that ruler, and now you can measure these dimensions. For example, simply like this. You click and drag, and you get the readings. Well, sometimes it happens that you measure by caliper or by any other method these dimensions, and you will measure 70 instead of 69. Well, still you can click at it and correct the dimensions, and that will set a local scale which will be applied to all the dimensions in the future. But I don't want to do that now, so I just skip that, and I start the ruler again, and I can measure any dimension. Well, you can see that I'm meanwhile zooming up and down by using mouse wheel, so it effectively zooms down or up relative to the position of the mouse cursor. So that way you can do some sort of panning. It's pretty handy. And you can always measure either the chamber size or the wall thickness. Of course, the dimensions are measured always with the precision of the image. So if the edge is not very sharp, you can't really measure the dimension very well. So it's important that your image is sharp enough. Okay. Similarly, as the distances or lengths and widths, you can measure angles. So I can put here a device called protractor, and I can move these points and measure the dimensions. Let's say angle of this chamber, or I can do it over here, then I measure the other angle. So I have lots of options like this. Okay. So this is very simple evaluation. Measure the shape. As the next option, we have the ability to compare the shape to a required DXF. Okay. You can simply click on this icon and load the final shape. Well, before I do, let me show you also other panning and rotating options. You can use your right mouse button to pan your image on the screen, up and down, left, right, and so on. You can also hold Control and by your right mouse button rotate this image. Okay? So I'm holding Control and rotating the image by right mouse button. Well, so now the next option is to compare the shape with the required DXF profile. We need to bring it, we have to have it prepared in a CAD, obviously. And then we can load the final shape through here. This is my final shape of the example 4, so I can bring it here. If I want to compare this DXF to the image, I need to change the mode, because now we are in a mode of editing photo. So we need to go to editing final shape. Okay. Well, in this case, you can you can use right mouse button for panning, but if you use left mouse button, you will pan only or move only your DXF. And then you can align it nicely with your shape, and then you see that it matches more or less over here, but doesn't match over here. You can see that the chambers gets very different in here, so we don't get really the dimensions which we want. Similarly, if I hold Control and use left mouse button, I can rotate this DXF only to align it better with the image. Okay, that is also needed sometimes because the profile gets bended because of cooling, because of shrinkage. So you can see that I can rotate it over here to get it matching my shape, and then again I can compare how well does it match the image. Okay, so that was comparing the DXF. I don't need the DXF anymore, so I can just hide it. Right here are icons for hiding. I can hide the image, I can hide the DXF or show it. And now I'm done with the DXF comparison. So I will go back to editing mode, and I will show you the last option, which is creating an outline. This is a very nice development also. Here what you can simply do is click on a few points like this, and then you're simply describing the outline of the profile. If you hit escape, you end it up, and then you can zoom and drag the line to match better the banded edge. Well, this outline is using Bezier splines, so editing of Bezier splines is always based on this on these directions, which you can adjust. You can adjust either these vectors, these positioning lines, positioning points, or you can just drag a certain point and align it with the shape. So with a little bit of experience, a little bit of practice, you get very good shapes with this tool. There's also another thing. Sometimes you need to have an extra point. You can just double click here, and that brings you an extra point, and you can reposition this very well. So you can see it this way. It's pretty easy to do a nice match of the shape. So you can elaborate this as much as you like. Let me skip this tedious work and I will show you directly the result. I have it here. This is my final shape. And now the only thing I need to do is export this to a DXF by using this button here. And then I can save it as exported DXF example 4. And then I can load it into CAD. So that is all regarding Profile Digitizer. It was pretty simple, wasn't it? Let me repeat the steps. To digitize a profile, you need to only calibrate your camera once and then do the 3 steps. Take the image using our digitizing board, bring the image into the computer and let it evaluate, and then simply evaluate the shape using measuring, using DXF comparison, or using outline and sending the outline to a CAD. Thank you very much for your attention, and feel free to download Compuplast Profile Die 3D with the VEL Profile Digitizer from our webpage www.compuplast.com. Thank you. Bye-bye.